We have another wonderful monthly event for today, a topic that is of interest to all of us. Sorry, Anil, go back to the mic. Which is an interest to all of us, which is in the space of artificial intelligence and machine learning, and we have an excellent program with a great speaker. We will get to that in a minute, but first the plug-in for TIE. As you all know, TIE is a global organization started in Silicon Valley in 1992. From its humble roots, it's now in 20 plus countries, 76 chapters. We have close to 12,000 members globally and about 2,500 charter members. And the sole focus of TIE is really supporting entrepreneurship. And TIE South Coast has been very active in San Diego since 2000 when it was first started by none other than Suren Dutia, who happens to be here. Suren, good evening and welcome. Today's event is a fantastic event, and there's been so much request to talk about what's going on in the space of artificial intelligence, and we are extremely fortunate to have a joint collaboration between Connect, TIE, as well as Analytic Ventures in bringing this program to you today evening. Our keynote speaker is Dr. Michael Zeller, and Tyson Schroeder, who's from Analytic Ventures, is going to introduce him just in a minute. But why this event today? No mystery, as you know, there's been an explosion of data that has been happening because of connected devices and IoT. And not only that, the computing power has increased tenfold, and then mathematicians are creating amazing algorithms to really make sense of what the data is telling us. So I was reading an investment banking report the other day which said, in 2015 and 2016, the amount of equity financing that has gone into the space of AI is close to $3 billion. And over the next 2 years, it's going to double. So you can imagine the kind of excitement that there is in the space. But with this excitement comes hype as well. So I think today's speaker is going to tell us what are the facts, what's real, and what's the hype, which is going to be great. And the other thing that we've requested Michael to talk about is if you're in an enterprise, how do you take this whole area of AI and deep learning and machine learning and really create an effective program within your enterprise, which is great. I'm in the senior healthcare space, and when I talk to, I think the challenge that a lot of us face is, when we talk to AI specialists, they are domain experts, but they don't have that vertical experience, and that's where kind of the gap is evident. But I'm sure Michael has a solution for all of that. So we're in for a great topic, and with this, let me introduce you to Tyson Schroeder, who's from Analytic Ventures. Tyson?
Thank you. Appreciate it. I'm with Analytics Ventures, and sorry, I'm not Naveed. Naveed was supposed to come speak today. He had a family emergency. I think he's on the beach in Mexico. Anyhow, so you have to take me instead. A little bit about Analytics Ventures. So we are a very early stage venture capital fund, and we essentially find the technology or the team or the entrepreneur and then build a company around that technology. And then we will seed that company. We actually also just are developing an AI lab, essentially a development studio, where we are going in and we are consulting to different entities around San Diego and elsewhere to help build out AI platforms, and that also cater to our portfolio companies. With that, a little bit about analytics. I want to introduce Michael Zeller. So let me give you a little background. Sorry, Michael, I don't have your bio by memory, so I have it here on my phone. So Dr. Michael Zeller, he's the SVP of AI Strategy and Innovation at Software AG. And then, by the way, Michael's actually been a good friend of the fund and the partners of the fund for a while and has spoken at many of our events and has done a phenomenal job and speaks about some very interesting things. Michael, right now, like I said, he's leading Software AG's strategy and innovation team. And he's also previously been the CEO and co-founder of Zementis. And they were big into the data analytics space and predictive analytics. Michael also serves on the board of directors for Tech San Diego, and as a treasury and secretary. He also serves the executive committee of ACM and the SIGKDD in the Premier International Organization. With that, I'd like to welcome up Michael Zeller.
on the beach. I think he heard that presentation maybe one too many times, but thanks for the kind introduction. It's a pleasure to be here. And I have to admit, I didn't know that Pi actually exists before I was invited to speak here. And I've learned a lot of very interesting things just looking at the different topics he had, the speakers he had in the past. It's amazing, so I feel quite honored to be here and presenting about AI and deep learning in the enterprise. Certainly one of the hottest topics on the planet these days, after the solar eclipse. But maybe before I go deeper into what we do in AI and machine learning, just a reminder that San Diego is actually a really, really good place to be for advanced analytics for AI and machine learning. We have a very interesting mixture, a very interesting talent pool. So if I can take San Diego over Silicon Valley, I'd do it any day. It's, looking at organizations like Connect or Tech San Diego. Tech San Diego has a data science roundtable that meets on a bi-monthly basis, really focusing on data science and collaborates with UCSD and their initiative around data science. So a lot of local activities, analytics ventures. If you're funding a company, if you're starting a company, you don't have to go to the Bay Area. Often people think, I have to start a company in the Bay Area. You don't have to. There's funding available, certainly here. And there's probably about 100 different companies in advanced analytics in one shape or another. And often say your struggles to have an identity. I think AI, machine learning, advanced analytics is actually one of our identities here. And Software AG is probably one of the companies that you've never heard about. So it's the second largest German software company after SAP, which you may have heard about. It's a public software company founded in 1969. So it's been around for almost 50 years, which is pretty amazing, given the state of the software, 1969 versus today. We do business in about 70 different countries. About 70% of all the global Fortune 1000s are existing customers. And about over 2 million developers are actually using our digital business platform to build applications, to integrate business processes, and to deliver solutions for IoT and many other industries. Software AG consistently ranks as a leader in things like streaming analytics or integration services, so classical middleware company, with analysts like Gartner and Forrester. And interestingly enough, Software AG came to San Diego as part of by way of an acquisition. So Software AG acquired Zementis, a company that I was a co-founder of and CEO until December. So in December we were acquired, and we're now here leading AI strategy and innovation, the AI product development of Software AG, serving as the global competency center or center of excellence for Software AG in all things machine learning, predictive analytics, AI. So with that, why are you here today? So that's my question to you. I'm pretty sure you're interested in AI, but I think that's not all of it. AI is the hottest topic, but why are we really here? And if we take one step back, what we're seeing is actually an unprecedented speed of change and disruption in industry across all different industry verticals. New business models are emerging faster than ever before. So it's really the change and the disruption that we see today. Like Uber, the largest taxi company in the world that doesn't own any taxis. Facebook, the most prominent, most popular media platform which doesn't create any content. Airbnb, the largest accommodation provider worldwide, which does not own any hotels. And who would have thought that Google would be in the automotive industry, but they're leading the road of self-driving cars. If you see them, it's pretty fascinating if you see those guys drive around in Palo Alto or Mountain View. So it's interesting, right? But what do all these companies have in common? And it's really AI, machine learning, and predictive analytics. All of those companies heavily invest and use advanced data science, machine learning, in AI to gain a competitive advantage. They have taken that technology and really made it their core asset to compete, to be assigning taxis and drivers more efficiently, to build self-driving cars, be ahead of the curve. This takes a lot of machine learning intelligence, a lot of leading edge teams to develop. So that's one common denominator, and that's why AI is really, I would say the race is on for it. If you look at what the most influential CEOs say about AI, Google's CEO said in the long run, we will be evolving in computing from a mobile first to an AI first world. The CEO of Amazon said it's hard to overstate how big of an impact AI is going to have on society in the next 20 years. IBM's CEO said artificial intelligence will affect every business decision soon. And an interesting bit from Baidu's CEO, I'm looking forward to China becoming the world's leading AI tech country. So pretty immense statement from guys that are leading some of the most valuable companies. And if that hasn't caught your attention, then let me quote one of our most brilliant minds of our century, Steve Hawking, and he said AI could spell the end of the human race. Now, while I don't think we're quite there yet, and the Terminator is not going to come walking down the streets, and Skynet is not going to take over the world anytime soon, I think I would rephrase that actually and would say AI could spell the end of your business if you don't pay attention to it. Because somebody will take it and disrupt your market and will take the business away from you. And if you look at market projections, I just heard that the venture capital investment is out of control in AI. If you look at this particular study, Tractica said the market for enterprise AI, so enterprise AI, not any kind of other AI here, will reach about 11 billion. And you can certainly argue about the numbers, a little higher, a little lower, a few billion here or there, doesn't make a difference. But what we will see is an exponential growth of the market. That's number one. And another little detail here is that Asia Pacific will actually eclipse North America in AI very quickly. And I just came across that Technology Review, MIT Technology Review magazine article here about who's winning the AI race. And it's clear China and the US are dominating the world of AI on the left-hand side here. But you can also see that China, since 2014, has published the most deep learning papers, followed by the US. So they have caught up very quickly and competing fiercely. In the US, the market is a little bit more condensed, I would say, around the big companies. You see on the right-hand side, the ones that are publishing the most, or Microsoft Research has always been on the forefront of AI deep learning papers. Google, IBM are catching up, Facebook is certainly out there, and Baidu is also following. So again, China and following. But here, I would say, if I look at AI companies that are leading the pack, it's more concentrated on the big companies, the classical names. In China, you have many different names that you've probably never heard about. But to an example to that, KDD, Tyson mentioned I'm also on the executive committee of ACM's special interest group of knowledge discovery and data mining, which is a global organization. We put together one of the leading data science conferences, machine learning conferences every year for the last 20 years. We just concluded one in Halifax in Canada, about 1,700 attendees. Last year, San Francisco was a very big event, 2,800 people. And it's one of the premier conferences to publish academic papers. So it's very hard. I think the acceptance rate is like 7% of all submitted papers. And it's also the premier conference to apply to publish applied papers. So industry applications, industry participation is very, very large. And you see that data science and machine learning is a very applied field. So it's less academic than it was a few years ago. It's really drifting heavily into industry and government and applied technologies. And what I wanted to mention with respect to Asia here is that last year and this year, I could definitely notice that the key sponsors were the usual suspects from Silicon Valley. Google, Facebook, LinkedIn, Twitter, up the road from Seattle, Microsoft, Amazon. But toe to toe, actually outspending them in sponsorship dollars and in aggressiveness to recruit data scientists were all the companies from China. Baidu, Alibaba, Tencent, Didi, Huawei. They were there to recruit the best machine learning researchers in the world. And that's why sometimes I have to chuckle when we're trying to compete here with Silicon Valley. San Diego, we're comparing ourselves with Silicon Valley, maybe LA, maybe Austin. But in data science and AI, the competition is global. It's fierce and it's global. So looking at this O'Reilly report, why are top companies investing in AI today? We realize actually that if you look at who is investing, every name is there. And it's not just software and internet, kind of the beginning top left and the bottom right, the usual suspects, but it is across all industries. It's financial services, it's manufacturing, automotive, telecommunications, retail, healthcare. Everybody is investing. You see also a strong correlation with the Internet of Things, another hype cycle that we're going through. Strong connection between AI and, I would say, sensor data that we're collecting, because what it means effectively is we're collecting more data, and in order to do something with it, AI is really the ideal application. And why do those companies really invest into AI is because they realize that AI helps them unlock the value in their enterprise data. This is the, I would say, natural next step after you've done your homework in business intelligence, you put BI systems in place, you've looked at as many reports as you can. Here's a way to really derive more value from the data that you've already had. And I would say it's also kind of a natural successor of all big data projects that are looking for a purpose. We've done our homework, we've collected all the data, we have a data lake. Now it's time to do something with it. So it's just perfect timing for AI. So why do those companies really invest so heavily in AI? If you consider that data is the new oil, then machine learning is really the refinery of that takes the oil and makes it extremely valuable. AI uses a data-driven approach as opposed to us writing code, writing rules, if then else. If this happens, then do that. Really algorithms that learn and extract value and extract knowledge from data is what we're using here. Statistical algorithms, you train them. Machine learning algorithms, you train them on the data that you've collected. And they will then, in turn, enable smarter decisions. And that's what we want to get to. Just training them is the first step, but really making smarter decisions that are more nuanced, more precise, and are, I would say, more complex than what you can ever write in rules. That's what we want with those algorithms. And I believe that AI will really deliver a core capability for any software application very soon. So you won't see the Terminator or the one uber intelligence, but you will see little agents in pretty much every software application that will help you to make one small decision just a little smarter. And if you multiply that by a million decisions a day, that makes a big difference. But here's what I think is the crucial point for AI really to be successful. And that is really, we need to deploy it faster, we need to make it easier to integrate it, and we need to guarantee a scalable execution of those algorithms as part of an existing IT infrastructure. You can't just rip everything apart and start over, but you need to be able to take these little agents and plug them into your existing systems, and allow us to do that faster and more efficiently without writing custom code every single time. Now, we have seen a pretty tremendous resurgence in AI in the last few years. I've been part of an AI research, and neural networks was kind of my thing in physics in research a while ago. And I always, I'm amazed at what we struggled back then and what's possible today. And then if you look at the flood of information, the amount of papers that are being published, or look at the Twitter universe, when there's, it's hard to follow all of that information. There's machine learning, predictive analytics, data mining, AI, cognitive, although that's mostly hijacked by IBM, deep learning, data science. AI, I'm really not the biggest fan of AI as a term because I think it's too generic, it's too flashy. I prefer to say data science or machine learning, the algorithms, what's really behind it. AI might be a good topic for kind of Forbes magazine, but what you want to know is what's in the box, right? What's behind that. So be more precise. And AI has had its ups and downs in the last 50 or something years. I think we had about 2 AI winters come and gone, where AI basically has come and gone and has failed to deliver on the promises. I know I was part of one of those winters as a researcher, and it was just simply ahead of its time, right? It was promised to solve everything that we trying to do today, like autonomous cars. But what's different this time around? Why do I believe that it's different this time around? And maybe a simple comparison is the Apple Newton or the Apple iPhone. If anybody remembers the Newton, I might be dating myself, right? It was simply ahead of its time. You didn't have a cellular network, you didn't have enough battery power, enough CPU power to run this thing. Add the apps on top of it. What the iPhone is today is it's not so much different, right? What Newton tried to do, but it was just simply ahead of its time. And likewise here, what we have today is we have more choices, more of everything. So on the data science side, on the left-hand side, we have more model diversity, more types of models. Many of those algorithms have been known for decades. The neural network is not a new algorithm. We know a few more tricks, and we know how to make it a little bit more complex now. We see more complex models. We can run bigger models that are now ensemble models or deep learning models that are really more powerful, but it only goes hand in hand with the right-hand side, which is the IT side. We have more data to train those models. That's what we needed. So we have more data, and not just more data diversity. We have video, we have audio, we have vibration signatures for predictive maintenance, for example. All of those things that we didn't have in the past, because putting sensors on devices is much easier these days than it ever used to be. And we can collect the data, and we can analyze it, which goes hand in hand with having more IT platforms. So you have cloud computing, you have Hadoop systems, massively parallel systems that can handle terabytes of data that are necessary, again, to train the left-hand side, the data science algorithm, in order to actually learn something that's useful. You have GPUs. It used to be the graphics computer, the gamers would use them, and suddenly someone realized, hey, I can use those to train AI models and be 70 times, 100 times faster in training. And suddenly, NVIDIA, if you look at the stock market, that stock has exploded. AMD even making a revival, because of the graphics chips. AI is suddenly a new topic for them. NVIDIA is building, a little pizza box for the car to power autonomous vehicles. Simply taking existing IT platforms that are now more powerful than ever, combining them with new algorithms, and the data that's now available. Suddenly we have those capabilities. And at the same time, we're able to update those models more frequently. You have to be able to train them and run them, take them into your operational systems to actually apply them. Because what's a model good for if you can train it once, but then never apply it in your operational infrastructure? And that's really, I think, where I see AI also is that gateway in turning data on the left-hand side into business value. Just collecting data is really not the purpose that we have. Right? We want to apply machine learning algorithms, AI kind of techniques to build predictive models, to predict something that's of value to my business process. So I have better business insights. But what I want to get to is decisions and actions. I don't just want to use those algorithms to create more reports or more dashboards. That's kind of the 90s, maybe the early 2000s. What we want is automate processes. Take those algorithms and make automated decisions on applying, on credit applications, on fraud detection. All of that can't wait for a dashboard for someone to print out a report and say, oh, there's fraud. By that time, it's a little late, right? So AI is really that gatekeeper between all of the data that we're collecting and making it part of our business process and creating business value. Better, more precise targeting in marketing, real-time responses, making it a better user experience on your website. Why is Amazon so popular? Because you get the right recommendations. It makes it easy to use it, rather than cumbersome trying to find an article and that others have already bought. So that knowledge, that data that Amazon has today is a tremendous competitive advantage to them, because they have a labeled database of products with images. Think about what you can do with that. So at the end of the day, data is one of the differentiators in the world. Not necessarily the smarter algorithm will win, but it's who has the better data to train the algorithm. That's why Google is probably always going to be the better search engine, even though Microsoft is spending an enormous amount of brain capital and real capital in order to improve their training. But it's simply the sheer number of users that will make the difference. And what I want to mention here, so in order to create more business value, we need to traverse from left to right as effectively and as fast as possible. And why is speed so important? Speed is part of data, of the value of data. The longer it takes, the more the value of data diminishes. It diminishes actually very quickly. The longer you wait, the less valuable your response will be. Think of an Amazon example. If I make a recommendation to someone who's shopping on my website, by the time the guy's gone, well, I've missed the opportunity, right? In fraud detection, someone swipes my credit card for a fraudulent transaction, I have to stop the transaction right there in milliseconds. Otherwise, I'm chasing after him after the transaction has happened, so it's not of much value. In the Internet of Things, if I have a transformer that fails in my power grid, it's too late to prevent the power failure, the outage, if I predict that after the fact that this has happened. So timeliness of applying those decisions is very, very important. And that kind of has, Forrester research actually called that perishable insight. And it's actually, it has two dimensions in my mind. One is just the time to act. If I have X milliseconds to react, I need to have an infrastructure that can do that. I need to be able to process 1 million transactions on my credit card system per second in order to make a decision every 20 milliseconds max. But it also means that I have to be very fast and effective in order to deploy, to utilize, to operationalize my algorithms. That's the second dimension. So if I build a fraud model today, I don't want to wait 6, 9, 12 months before it is actually in my operational system, because by that time the fraud patterns have moved on. So rapid deployment is a very, very important time scale as well. And one important solution, and now I'm going to get a little bit more into the technical details here. One important solution to achieve that agility is an industry standard called PMML, the Predictive Model Markup Language. It's basically a model exchange format. It's not rocket science, it's an XML definition of my models. It's defined by a group called DMG, the Data Mining Group, and it's actually been around for more than 10 years. But it has taken quite a while for it to become popular, because 10 years ago we didn't have many models. We could, if necessarily, code them in C, in Java, in SQL. Today we have tens, hundreds of models, and the models have become more complex. It's no longer a linear regression model. It's maybe a random forest. It's a deep neural network that I don't want to hand code every single time I change something. So an exchange format, a common standard and a common process for all stakeholders becomes imperative for agility. It's already supported by all major data mining tools, so that's open source as well as commercial tools. And it really eliminates the need for custom coding proprietary model deployment solutions. So it allows us to kind of develop a machine learning algorithm in one tool and then deploy it into another platform. And that's, you will see that in the next few slides, I think a very essential element of being nimble and being flexible, going into the future in a rapidly exploding field like AI. Because there's so many new algorithms, so many new tools. It's a very fragmented market. As an enterprise, it's very hard to pick which one I'm going to use for the next few years. I need to be able to use whatever I come across next month. Think of this as kind of the PDF of predictive models, so to speak. So it defines a common standard process for all the stakeholders. It accelerates the time to value for your predictive models. And shows transparency. Now that we're deploying complex decision models that make mission-critical decisions for our business, we need to have transparency and really understand what they do. It's a simple way of fostering best practices. Think of it as not a software development lifecycle, but a model development lifecycle. Same rigorous process has to be used. But it helps us to transform AI and predictive models, machine learning models, into more dynamic business assets. And if you look, under the hood, think of it, PMML, the Predictive Model Markup Language, as your mini machining workflow. And what you realize here, it encapsulates quite a few things. And the model, the predictive model, is just one step in the middle, right? Because data scientists, unfortunately, don't spend extremely amounts of time on just the model, but they actually spend a lot of time on data preparation, pre-processing, post-processing, in order to normalize, discretize values before they get fed to the model. Afterwards, you need to scale, you need to map it into business decisions. So maybe the output is not just the predictive score probability, but it's actually approve, decline, fraud, alert, a business decision. So the model actually is flanked by pre and post processing, and the model itself is just one box here. But keep in mind that this can be a very complex model. It can be an ensemble that has in itself hundreds of submodels. So complexity is a little masked here. And if you work your way to the front, what you get in addition here is something that you also have to be concerned about. It's input validation, outliers, missing values, invalid values. Because if you build models, you usually cleanse your data, you have time to massage it, you look at it, you spend a good amount of time to prepare it before you use it. Now in the real world, in your operational system, your data feed may be dirty, it may be broken, it may not get all the values, it may have outliers, missing values that you didn't expect. And for that, you need to protect your model from not making bad decisions. Small, intricate details, but very, very valuable if you take models and rapidly deploy them. And then likewise, the model signature at the very front gives anyone who takes that model, an XML file of the model, a very easy understanding of what's the input and what's the output. And that's all they need to know. This model needs age, it needs income, it needs, there's an integer, and it's a real value, and it's a value between X and Y, and it returns to me a probability between 0 and 1. Looking at that, anybody on the IT side can take that model and deploy it and integrate it. Otherwise, you'll get a spec with custom code, something magic happens in the middle, and every time you have to update the model, you would have to redeploy, retest, re-QA the whole system. With this, you kind of take the model and move the asset. So at the end of the day, the model itself has to be treated as the business asset, not the underlying infrastructure. And what's important here is that we have that flexibility on both sides. So assume we have a common standard to represent these models and make them our business asset. It gives us the flexibility on the left-hand side to pick different data mining tools, because data scientists are rare, they're hard to find, they're very expensive, and they're very opinionated. I get to say that because I consider myself a semi-retired data scientist. So if you have someone who's trained in R, they may not want to use SAS, and vice versa. And in order to make them most productive, you want to give them the flexibility of to choose whatever tool they're most productive with. And likewise, tools come and go. That's one part of, especially in the open source world, there's a new tool every week. So you want to be able to use all of them. Maybe a collection. Maybe you have teams across the globe. They all like different tools. Likewise, different machine learning techniques. Deep learning right now is all the rage, but we have lots of other things that do a really good job in most cases. Decision trees, classical shallow neural networks, naive Bayes classifiers, random forest models, which were very popular, but are still very popular, booster trees. Again, so maximum flexibility on the left-hand side for data science, and likewise on the right-hand side, maximum flexibility in how to deploy that. Again, the model is the business asset. Left and right side should be able to change in whatever shape or form they have to. It shouldn't matter if I deploy this model in the cloud today or on-site tomorrow. If I run it in a mainframe or in a Hadoop system, if I have to do it in batch mode or in streaming analytics in real time, it should not matter to the model. The model, the business asset, need to be able to plug it into different infrastructures and run it depending on the business need. Now, deep learning is really one of the hottest topics. Let's take a closer look at that. And it becomes more complicated as we dive into that one. Now, it has taken the machine learning world by storm. Similar to what happened, if you've been following that, a few years ago, there was a contest called the Netflix Prize, predicting what movies do viewers like best, what do I recommend. And Netflix had given out a prize $1 million to beat the algorithm by 10%. Through that contest, suddenly we saw a rise in ensemble methods. Random forest was suddenly one of the most popular algorithms. We've never really seen it before. Complete ensemble models. All the teams started combining their models, so a bunch of bad models suddenly became better than the competitor. It's actually a very, very interesting, intriguing result. But with that, model complexity suddenly exploded. And likewise now, deep learning is taking really the world by storm. It has broken one record after the other. I've never seen it happen that fast, that we're breaking records in image processing, recognizing certain images. ImageNet is one of those other competitions. Or speech recognition, improvements there. Very significant leap has been achieved in the last few years. It's demonstrated incredible talent at playing games. The Google Go that was widely advertised, or even the good old Atari games that the DeepMind algorithms team used to train it on. So it's been fascinating to see how quickly this type of algorithm. And again, deep learning is, again, a family of different algorithms. It's not that trivial to say it's one or the other. There's a few classical cases that I'll show in the next few slides, but it's still, again, an umbrella, I think, a topic for many different sub-algorithms that just happen to be deep, more layers of a neural network type. And interesting in that market is that open source actually leads the way. That's a rapid development, and it's out of the fact that a lot of the open source libraries were sponsored by companies like Google, Facebook, Twitter, and the industry there, data science or data mining industry, has been fragmented before. I think is struggling now to look at this open source collection that really is the only choice in deep learning these days. And there's a number, TensorFlow, Theano, Caffe, Deep Learning for J. Those are the ones we work with. MATLAB's kind of the outlier here. This was from a poll saying what are the top data mining software for deep learning. And MATLAB being the only commercial in that list. So that's an interesting element. And also, by the way, I think I mentioned earlier, GPUs have become super popular to train networks. And while it's important for training, I'll actually talk a little bit more about the operational deployment. In the enterprise, more often than not, you probably won't need GPUs to run the algorithm after the fact, unless you have very hard period time constraints. So open source is leading the way. It's a very fragmented market, a very rapidly evolving market, so it becomes even more important to have one common deployment capability. So having an open standard that can represent and say, okay, today I use TensorFlow, tomorrow I want to use Caffe, and I have deep networks in both, and I want to deploy both in my IT infrastructure. I can't, just take open source software and drop the code in there. We all know if you're in enterprise technology, open source is already a bad word, and then if you look at the licenses sometimes, it's going to cause more trouble than not. Likewise, open source is great. I'm a big fan of those tools and the open source community there. Tremendous rapid evolution of tools, but not necessarily for the enterprise, for the deployment. And if my desktop crashes while I build a model, so be it, I restart it. But if my fraud system at a major bank crashes, different scale of an impact. So I believe that while it's essential to use those tools and very good to use them in building software, for the operational side, we want commercial vendors. We want a commercial platform that I can rely on, that has SLAs, that I know who to call up, that it runs 24/7, that has, can guarantee response times and can scale across multiple systems. That is not to say that you can do it other ways, but what I've seen is the only guys who can manage to do it with open source are the Googles and the Facebooks that have an army of very, very, very talented people that can get it done, that build that kind of organically. Every regular major, I think, enterprise company, like a financial institution, a manufacturing company, a retailer, I would not like to venture into deployment of open source tools and trying to manage that part. So that's why I think the handover between open source and commercial is still a really valuable play for an enterprise software company. Now, deep learning, even more details here. As we said before, shallow neural networks have been around for a long time. 20 years ago, the state of the art was a 3-layer network, one input, one output, one hidden layer. That's all we could make converge because limited data. A few other tricks have come along the way, namely the convolutional layers and some other small tricks. But overall, it's mostly data and CPU, raw CPU power that we can throw at this. Now this is LeNet. It's a convolutional neural network, and it was used, first published by Lacan in 1998. So it's been around for a few years for recognition of digits, handwritten digits in the bottom right. It's sort of the hello world for image recognition with convolutional neural networks. And we use that, for example, with one of the open source tools called Caffe to train it. It has 2 convolutional layers, 2 max pool layers, 2 fully connected layers at the end. So at the front, you basically show an image. At the end, it will tell you which of the 10 classes it belongs to. So 2 on the front, 2 in the back, hopefully. At least the one with the highest probability should be the 2. And this one was typically trained with MNIST data set, the standard data set that's out there for anyone who's studying data science. They will do this day in, day out. That's one of the, again, hello world data sets. 60,000 images, and the images are 28 by 28 grayscale. So that was the state of the art of deep learning networks in 1998. But again, a very interesting achievement to just recognize all these digits and not make too many mistakes. Now fast forward to 2014, from 1998, from LeNet to 2014 with a cryptic name of BGG16. And there's other BGGs, but this is called a very deep convolutional neural network, and it's really for large-scale image recognition. It was the winner of the ImageNet Challenge in 2014, and it predicts basically the category that the image, a few samples on the bottom right, belongs to, and it covers a diverse group of about 1,000, of exactly 1,000 categories. So you have airliners, you have beer bottles, you have lots of pets and dogs and cats and whatever else there is, signs, bicycles, a lot of interesting real-world images. Now that network is slightly more complex. Now we have 13 convolutional layers, 5 maximal layers, 3 fully connected layers at the end, and it outputs basically the probability for each of the 1,000 classes. The training data here is up to 13 million images, and it's 224 by 224 color. Like what we had is 60,000, 28 by 28 grayscale. Now we're at 13 million, 224 by 224. And this network was actually really good performance. So the top 5 performance, which is usually measured, is 7% of an error, which is on par with human performance. You know, people make mistakes of what kind of a special cat it is, things that we wouldn't really be able to differentiate easily either. But very impressive performance. Now, where I'm going with this here is that complexity with these algorithms is a real challenge. I think I should not show yet, but anyways. So left-hand side, so concentrate on the left hand, don't look at the right yet. So complexity of those networks is a challenge. So LeNet was 2 layers convolutional, 2 fully connected, about 18,000 neurons, 55,000 parameters to train, to iterate over. So sizable, network as compared to maybe 20 years ago where we had a 3-layer network with 100 neurons max and a few hundred connections. Now VGG is up to 15 million neurons, 151 million parameters to adjust to train. So complexity is really, really exploding. So that's one of the challenges in those algorithms. And so what that means, it's even more important to have a common exchange mechanism, common standard like PMML, to move those, to deploy those across different platforms. Because you can't hand code this, you can't easily move it otherwise. You need a common mechanism to represent this. Otherwise you get in trouble very quickly, and it's a very specialized solution that may work today, but is outdated tomorrow. And with that complexity actually comes another little secret. That's the right-hand side. Now you're allowed to look at that. We really don't know how those algorithms work. And that's the shocking truth, actually. So there's no rigorous mathematical theory how to construct those networks. How many convolutional layers do I need? How many neurons do I need? How many parameters? It's trial and error. And that's, unfortunately, we should be ashamed of that's the state of the art, but it's experimental. So there's a lot of work left to resolve that magic, basically, of a data scientist constructing these networks that happen to work really fast and win certain competitions. So it's all experimental, and you win a competition, and suddenly your network is being published and is the most popular one, but nobody really knows why Region 16 works better than XYZ, except it performed better. Right? So there's no mathematical proof right now. So a lot of work left for data scientists to understand the fundamental of deep learning. Fundamentals of deep learning. So to address those challenges with complex models, frequent updates, cross-platform deployment, what we emphasize as software AG is actually a vendor-neutral platform approach. I think that's very essential if you look at the strategy, the roadmap of an enterprise company. So our focus is the right-hand side, kind of the operational deployment, the integration, and the execution. We don't really touch the left-hand side, the left column development, where the data scientists kind of tinker with algorithms. We want maximum flexibility on that side for the choice of different tools and different algorithms. So your classical algorithms, as well as your most advanced deep learning models, it should not matter. The business asset is the model. That model then needs to move quickly from left to right again rapid deployment through one common standard, flexible integration with the existing data sources and processes. Again, that's where an open platform-based framework comes in. You need to be able to plug it into the existing processes, not rip everything out and start over. And you need to be able to run it effectively. You need to be able to scale it, permission critical results. So that's really key. Yeah. And why is a kind of an open framework so important here? Not just a plug for an enterprise software company, but really, if you look at your strategy, your roadmap, you don't really know where you end up in a few years. Take the example of IoT. Internet of Things has hundreds of vendors today. Everybody has like a little point solution. But at the end, I think Gartner said that actually you don't buy an IoT solution, you assemble it. You pick different building blocks. I think of it as playing with Legos. I have these device management pieces. I have my database. I have my big data platform. I have the streaming elements. I can assemble that as and when I need it. Because the only thing that's for sure is the requirements will change. And likewise in AI and deep learning, we're just at the very beginning and the algorithms change all the time. The data sources change. In order what you need to build and to deploy those algorithms, you don't know yet. A few years ago, if anyone had said deep learning, deep neural networks is going to be the rage, we're going to have gigantic networks that will solve image recognition. Anybody in the image recognition community would have said, yeah, you're crazy. We need to feature engineer everything by hand, and then train a small model, and then we eventually solve a certain problem. Nobody had expected that. So the only thing is change, that's for sure. So you need to keep that agility, that you have different building blocks, different Lego pieces that you can plug together. So before we conclude, let's take a look at some actual use cases where we see that AI already is being used. Machine learning techniques are being used every day today. IoT, one of our large partners is Bosch, for example. Bosch is probably top tier, the largest automotive manufacturer, automotive supplier in the world. Build everything from fuel injection pumps to spark plugs, electronics for all sorts of pieces in the car, but even your cell phone. The Apple iPhone actually has motion sensors in it that are from Bosch. So 375,000 people, large contingency of data scientists, and they selected us as one of the partners to standardize for their Internet of Things strategy, their IoT cloud. Key use cases are predictive maintenance, quality control. If you produce parts all across the world, think about airbags. One other company got in trouble by having airbags that 10 years down the line didn't really work so well because the sensors were malfunctioning. Somebody had tinkered with it and nobody had noticed it along the way. That's a very big challenge. Those elements have to be controlled very tightly, and so with the IoT strategies in place today, you can actually measure, test, validate, and then save that data along the way. The financial and the insurance industry is probably, I think, at the forefront of adoption of machine learning. They've always been kind of the leaders of the pack. If you think San Diego, actually, HNC, which later was acquired by FICO, was probably the first commercial success of a neural network for credit card fraud detection. Classic example, born here in San Diego. So we work with companies like Equifax, Fiserv, Western Union that actually leverage our solution to deploy fraud detection models, risk scoring models, all across their infrastructure and throughout different countries. And then customer analytics, so financial insurance industry, real-time fraud detection, risk scoring, probably the most prominent use cases for machine learning models. In marketing applications, it's cross-sell, upsell, recommendations, and they're one of the big cruise lines. If you get a recommendation to do spend your money in a certain place at the ship, that's a recommendation model that looks at your patterns and how you spend and what you do, other people like you do, and makes a better recommendation. So Also, if you see the impact, for different decisions, it's something that we have to think about, how to validate the results of neural networks and machine learning models. This is going to be a challenge in the future. If I make a bad recommendation, show the wrong ad to someone, send you the wrong coupon, not too bad. No harm done, I guess. Maybe an upset customer. But if I approve a loan that I shouldn't have given to someone, it's a much more severe impact. If my device fails, it's mission critical, my jet engine fails, now I really have a problem. So looking at how to validate models under different scenarios is not a trivial solution. Validating self-driving cars, I think, is an unsolved problem. That complexity of the system, given all the humans surrounding it, it's going to be the biggest issue. But here we are at J&J Labs, right? So transforming healthcare with AI, I think, is one of the biggest opportunities we have. And healthcare has been, I think, an embarrassingly late entrant to the data-driven and machine learning game. A simple application here, I would say, it can be as mundane as reducing waste and abuse, right? We want to improve quality of care. We optimize, but we also want to optimize our resources and reduce the cost. So by reducing waste, just abuse and fraud, false insurance claims, and not ordering the wrong tests, that seems mundane, but it can save billions of dollars. If I'm in a hospital, I want to optimize my beds. If I can predict the length of stay for every patient that comes into my hospital, I can more effectively manage what I have on every floor. I can assess readmission risk. If I discharge this patient today, is he at risk to show up tomorrow again? And only that only got the attention of a lot of the hospitals after the government put some financial incentives around that. So Medicare and Medicaid are kind of penalizing you if you have too high of a readmission rate. But think about medical imaging. Convolutional neural networks have broken every record, so why not look at detection of cancer? Giving the radiologist some help to focus on the real cases rather than doing hundreds and hundreds of images. To be scalable and cost effective, we need some assistance to doctors in their care. And likewise in clinical research or drug discovery, we need to be able to lower the cost by managing how we use data to be more effective at finding the drugs, the compounds that are most relevant, and most likely to succeed in a trial. I think these are phenomenal use cases where AI can make a big impact. And we're just at the very, very beginning of that. Probably a couple of reasons that medicine hasn't been driven by computers as much as other industries in automation, but also by the fear of privacy. How do you protect patients' data? So that's probably another thing, and just availability of data. But if we can truly look at a population and impact of a drug across the entire population rather than at a clinical trial with 10 people or 100 people, it's a whole different game for statistics and machine learning. So I'm pretty much running out of time here, so let me just fast forward. And I wanted to say that what we do is on the operational deployment, and obviously for machine learning, we've seen that people say you would need GPUs, but in essence, you can do most of the things unless it's really, really hard, real time, like a self-driving car. You can do that on traditional enterprise hardware and software. Run this in Java, run it on a traditional server, run it in the cloud. And this is one of the things that we did here in real time. We're recognizing basically submitting images from a mobile phone to a cloud server. One is basically that example using the handwritten digits, but it's taking the image, it's sending it to the cloud, it's coming back with a result. The prediction is just under the image here. So I'm writing here by hand a 5, and it's sending it to the cloud, coming back. So what it demonstrates is that the cloud can serve decisions fast enough. And even if you look at objects, you can basically pick images, you can transfer them across the net and back. That's not to say that there's a lot of talk about edge computing and edge analytics. So you could also move that decision, of course, onto the phone itself and run the same algorithm on the device, which our phones are so powerful these days. You have a multi-core processor, a CPU, enough memory that most of the things you can also do locally. But at the same time, you get a management overhead in deployment of that, managing all of the devices. Is something you have to, it's a trade-off. So you can choose if you run this locally or if you go across the net. But what that shows basically is that you can deploy that today. You can deploy it in easy and very manageable way, and you can update those models. If I have a new model tomorrow that can detect some other object, I just basically swap in that model, and I have a new capability without changing any of that chain of how I use the data, how I integrate the model, and how I basically, how the end user perceives the application. That's the advantage. So I started the presentation with a quote from a famous physicist, to scare you, right, from Stephen Hawking. Let me end it with another physicist's quote, one of my favorites here. Albert Einstein said, "Information is not knowledge." And that was, of course, way before there was anything around big data or machine learning. So he coined that phrase way before that. But what the essence is, it's not to collect all the data is our point, but what we do with it. Turning that data into knowledge, turning it into business value, to make smarter decisions, to build more intelligent applications. That's the ultimate goal. All of this big data brings, I think. So AI is precisely that tool to do that. So I would encourage you to apply your knowledge, to invest in AI, to experiment. That's the most important part. Even if you don't have a clear path to the end goal, start investing, start exploring what it can do with you, for you and for your business. So imagine what you could do, what business models you could implement if you had AI in your business process at any point. You could make smarter decisions. So envision that part. If you could do that, deliver more precise results, and give your customers a better user experience. So I think the future of AI in the enterprise is already here, and it's very, very, very bright. And the only thing I'm really sure of is that it will impact your business significantly. So that's the only thing I'm sure of. How and when and why, that's up to you to decide, but it will impact you. Thank you very much. Questions? Do we have a mic? Oh, please.
Excellent presentation, Michael. I have two questions because I don't want to ask again. Number one is regarding healthcare. So the healthcare is the most, it has a direct impact on our lives, so is HIPAA coming in the way of AI? Number one. Okay, and the number two question is that you mentioned about AI for enterprise and using only branded products, MATLAB, and they're prohibitively expensive. Because I run a software company and I build softwares, custom softwares, and just the cost of the software make people faint. Even the mid-sized companies who are earning up to $15 million. Okay? So these are the two questions I have.
So HIPAA and healthcare, I think, will come along. I believe cost will be, at some point, the crushing driver of everything. We can't afford to continue how we have in the past, so that will force us to use new technologies. And I think that will, once we solve kind of the privacy concerns, regulators get a handle on that, I think we'll come along pretty quickly. In terms of enterprise software, I think we're going into the right direction with cloud computing and a kind of a pay per use kind of models, pay-as-you-go models, not the classical enterprise way. And I know a lot of enterprise software companies have their challenges with that. Open source is clearly, if you can manage open source, it's a viable solution. But if you're running Wells Fargo or Bank of America, you know, they still rely on mainframes for many of their enterprise processes because the change cycles are so slow that this software that gets deployed today will have to be supported and it will have to be, you know, backward compatible for the next 10 years. And you can't expect that to happen in open source. The way we've seen that, you know, we made the transition from a small software company to now being part of, you know, through the acquisition of a large company. Certainly a different scale, but we're struggling just by looking at tools in the Hadoop space, for example. Supporting one of our products runs on Hive, one of the open source databases that runs on Hadoop. But there's so many iterations and so many releases that it's really hard to follow every release cycle and test against it and validate it and ensure that the customer that then pays for your product can actually rely on it for mission-critical applications. So it is a challenge also for software companies to kind of support in that space accordingly. So now I understand why it is so expensive to have a maintenance contract. But you can also call those guys up and scream at them if it doesn't work. Sorry, I don't want to make you run around, so maybe you first.
Yeah, my question is, which use case do you see most prominent use case in AI from a revenue perspective?
I think currently IoT has all the attention from manufacturing companies. I might be a little biased because our footprint is very strong in Europe, especially in Germany. Industry 4.0, how it's called there, is very much the focus of a lot of the manufacturing companies. So I see quite a bit of investment going in there. But even in the financial space, I see kind of a similar level of investment. So between the two, I would say it's a toss-up.
Thank you. I think it was a fantastic presentation, the way you structured it. I liked it a lot. I'm a data scientist. I have a quick question. You separated out the development aspect from the deployment aspect, right? And I noticed that the new cloud solutions like Microsoft Azure, ML Studio, right, where you can deploy very quickly,
Yes.
and then have a web service that can be called, like you mentioned, it's the core of an app,
Yes.
right? And you can call from the mainframe app, right? So how do you think that will disrupt the traditional way, like what we used to do for a long time now takes minutes.
Mm-hmm.
So I would like to hear your thoughts on how it's going to change.
Yeah. So you see a similar trend. What he's describing is Amazon's machine learning environment driven by the cloud. Likewise, AWS has something similar. Google has something similar. So machine learning on the cloud. What it still is a single end-to-end, single vendor solution. Right? It happens to be in the cloud, and I think the strategy behind that is everything to be centralized on that particular cloud, because that's how they generate revenue. So you have to ask yourself, what's the revenue model and the incentive for that particular company behind it, and it's simply to drive usage of their cloud infrastructure, nothing else. So they even give away most of the software for free, as long as you run it there. But you're locked into that cloud, you're locked into that particular model, you can't usually get it out.
So does PML have to move my model to a different cloud?
Yes, ideally, you build it in R, you run it anywhere. That's the idea behind that. And I have to say, Microsoft, Amazon, Google, they have made it fairly easy to kind of expose an endpoint. So you train a model, you upload your data. In many cases, you train a model, you don't even know what algorithm runs there, and you get a model and a web service API to call to reply to new data. And I've seen that. It's very, very interesting, very intriguing as a use case. But again, you're locked into their model, their cloud, and you don't know what the algorithm behind the scenes is actually doing. So
trade-offs.
Very comprehensive presentation, thank you. And particularly I enjoyed your comment about open source and the reality behind open source and what happens there. But my question has to do, because this is a group of entrepreneurs or wannabe entrepreneurs, from your Zementis experience and from some of the comments you just made about being locked into some of those platforms, can you comment on entrepreneurs and their opportunity in this whole field, so that they don't, I've seen how small companies get, the Googles of the world can overtake very quickly once they find out what somebody's developing. Any comments there, guidance?
So I think AI, machine learning in general, is a really ideal field to start a company right now. So this is a fabulous time. I mean, when we started Zementis, it was actually a while ago, and we thought this was easy and everybody needs that. But it took the market, 5, 6, 7, 8, 9, 10 years to catch up. So long road. This is the time for AI. This is the time to play with it, and this is the time where you can differentiate yourself. The tricky part right now is to compete on data scientists, so the workforce, because Google, Facebook, and all the other companies I mentioned along the way are paying a premium to hire the brightest data scientists. They're using their cash to attract the best talent. And that's been difficult for the rest of the world to compete. So it's not a level playing field in that sense. For startup companies, you're attracting a different kind of, I think, talent pool. Someone who wants to work in a small environment, wants to make a difference, has an entrepreneurial spirit. I think you're not necessarily competing like a Bosch would compete with a large company, but as a startup, you're not competing with a gigantic company usually. I would say with open source, it's easier today to get started. You need less funding. You can get things done on the cloud. You can rent the servers when you need them. So you can bootstrap much more effectively than you could do that in the past. Then of course I'm torn because all the VC capital that we heard is available today, millions of dollars. So the Series A suddenly is 10 million plus. You have to kind of find your balance. So I don't know if I answered your question there, but it's probably open-ended.
Thank you.
We have more questions over there also. I let her choose. So.
Hi. Really enjoyed your talk, but I'm actually starting in systems biology, and one of the aspects in healthcare and in research is the fact that inferences are really important to understand how underlying networks, essentially work. And one of the interesting things with deep learning is it has so much power to tell us a lot of predictive information. But I wonder, is there a possibility to utilize that for like systems identification or for inferences essentially into networks?
If you have enough data and enough examples, I would assume that there are use cases. But I would do a search on your topic and see if there's any bright papers that have already been published in that sense. I would think you would see applications in fields where there's a lot of data available and a lot of kind of reference points. If I do this happens. Kind of supervised learning is probably much more advanced than unsupervised these days.
You talked about many use cases, but you didn't talk about the big use case that Elon Musk is referring to and scared of, use of AI in warfare. Where is the field in that area right now?
Well, I think with every great technology comes a great responsibility. So there is clearly a path to using it for drones and driving vehicles in the battlefield rather than civilian cars on the road. So I think what we need is a clear discussion about what's feasible and how to control the different applications when it comes down to it. Abuse will always happen. With every good technology that we've seen, nuclear energy, and you can turn it into the worst weapon that there is. So that balance, I think, politics has to figure out where we set controls in place that we don't deliver AI kind of drones to the wrong people.
Nowadays, vehicles are the weapons.
Yeah.
So just put a
So,
self-driving vehicle in a pedestrian area.
Yes.
I have two questions. The first one's really quick. You talked about the complexity of sanitizing the data, cleaning the data before it gets fed into the model. How come there's no AI to actually clean that?
Good question. There are more and more companies that I see that are trying to build models for automated training. So just give it the data, it figures out what are the distributions, what are the outliers, and kind of tries to do some of that cleansing automatically, but we're not quite there yet, that's true.
Okay, and the real question, you mentioned this PMML markup language, and then you described how in your vision, I believe it's a vision, that if these open source frameworks adopt this as a common input language, then you can then have a portable model. But the model is actually built in the open source framework, right? The PMML is simply the framework. Is that not right?
Yeah, it's basically the representation after the model has built.
After the model is
After
built.
the model has been built. So if you have a model that's been trained, how do you take that model and make it portable? How do you represent that? And so there's a markup language, it's basically an XML representation of that model that says this many inputs, this many neurons, this many these are the weights. So that's basically the representation.
And then that could be ported into, so you're essentially saying if this infrastructure were to exist and everybody adopts it, then you have a framework in which you could take this and put it into the different open source frameworks. In the end, what would be the differentiation of the open source frameworks?
The open source framework still builds the model, so there's still a differentiator in how to build the models, how to use it, your preference of using one tool versus the other. It's basically an open market, right? It's just downstream, I have an easier way to manage 5 different models from 5 different tools, because me as the IT owner, I have to ensure that all of them run in the same way. And
is there an accuracy difference at all?
it shouldn't be, so that's up to the consumer. So there should be producers, and there are producers, and there are consumers today. So there's actually, if you look at the dmg.org website, where you see all the supporters, all the tools are Python, SPSS, SAS. So all the supporters are there. You see what they do. It's basically exporting it from one tool, enabling the export, and then the consumer can take that model and run it. And of course, you have to make sure that the accuracy is exactly the same, which is sometimes not trivial.
Just a clarification, it's just a model description, not the model itself, right?
It's the description of the model as it has been built. So it's basically something that you could interpret and execute. Oh, we're out of time, sorry. So I think there's a hard stop here of me getting kicked out by security otherwise. So I don't want that. So thank you again. Thanks very much.
I just want to put in a plug for next month's event. You should have had this slide that is sitting in your seat. Is Abhay still here? Abhay, do you want to just give a 1-minute description of our next month's event? Abhay is kind of the organizer for our September event.
So we are all talking about healthcare, though it's very important discussion. Did you know that nearly $36 billion are spent in this country on drug development, and yet 75% of the cancer patients, they do not benefit from the drug. So bottom line is how we can eliminate the inefficiency in the system. One of the things we'll be talking about next month is looking at targeted therapies. For example, in cancer, the model has been where you try one drug, it doesn't work, you try the second, and the third, and the fourth. So for patients who are suffering from cancer, for them, time is of essence, days matter. And with the targeted therapies, it would be relevant to get to the patient in quickest possible time, take therapy. So that will be the topic of discussion next month.
Great, thank you, Abhay. It's 26th September, and make sure it's not here. It's at the offices of Kenobi Martins in Carmel Valley. And I see a lot of new faces today, so I hope you found this talk very useful. We have these talks all through the year. We'd love to have you as a TIE member. Please see me or Preeti, our executive director, if you have any questions. We'd love to have you. So good night, everybody, and thank you for coming.